a little hell.
Okay, so we have created a door stopper, and the thinking behind our design is that normal door stops will act as a wedge between the floor and the door itself, and so when the door closes, it encounters the wedge, and friction between the door and the wedge will stop the door from closing. The problem with this design is that not all floors will provide enough friction on the wedge to stop the door from actually closing. When this happens, the wedge slides along the floor and it accomplishes nothing. So instead of relying upon friction, we have created a wedge that will fit into the gap created between the frame and the door itself. When the door opens, there's a gap right by the hinges that is created, and if the door opens more, the gap goes bigger. When the door is closed, there is no gap at all, and that's why we've gone with the wedge. We're using a 4-bar linkage, and we've gone with the spring right here to pull this side down. And when that happens, these bars come this way, which causes the wedge to extend into the gap. When this happens, the door cannot close any further because it will get stuck on the wedge. So this is our original design for this door stopper. It is a 4-bar linkage with the top handle and the base forming 2 of the links. There's a 3rd link in the middle, and then the wedge itself forms the last link. So the basic operation is that there's going to be a spring running from these 2 hooks over here. And so in the locked position, the spring will be extended. To unlock it, you lift that locking mechanism, and then the spring will pull the handle down. And the distance between the 2 hooks is getting smaller as it comes down, and then the wedge extends as a result of the spring pulling down. So in order to lock it back into place, you're going to lift the handle back up, back to its original position, and then you're going to take the locking mechanism and slide it back down into place. So what will happen is the handle, the spring will try and pull the handle down, but it can't do it because of the locking mechanism right there.
For this design, we wanted to focus on ease of use. So as you can see, it is a 4-bar linkage with a spring attached, and the spring keeps it in its current up position. And to bring the wedge down, what you have to do is step on this block here, and when you do that, it comes down like this. The wedge will come down like this, and this part will come up. Once it is in that position, it'll stay locked due to how it is oriented, and the spring will actually keep it down in that position, and the only way to bring it back up is to push down on this link right here. Once that is done, the spring will pull it all the way back up to its original position.
Do note that it is using a first angle projection, and that they are in all the dimensions are in inches. This design is essentially a 4-bar linkage with a spring attached. A user steps down on this block against the spring and to put the wedge into the down position. In this position, the wedge is locked in place, as you can see. And to unlock, the user steps onto this link here and must overcome the spring. Once past this point, the spring pulls the wedge into its original position. This is the upper limiting position. The limit is caused by this contact between the wedge and this block right here. And this is theta 2, and it's about 68 degrees in this position. The down limiting position is caused by the contact between the base and this block along this edge right here, and theta 2 is about 4 degrees. The mid position is where the mechanism will actually stay static, and if the angle is less than this, the spring will pull it into the down position, and if it is greater than this, the spring will pull it into the up position. This is a diagram for showing like the required force to overcome the spring because you're trying to bring it from the up to the mid position. In this accompanying graph, as you can see, you'll need a maximum force of about 3.5 pounds. This is the graph for the force required if you're pushing down on this link right here to move the mechanism from the downwards to midwards positioning while overcoming the spring. And this is the accompanying graph, and as you can see, the max force is about 0.8 pounds. This is the code for the force required for when you're trying to move from the up position to the down position. And as you can see, when it gets ran, the maximum required force is 3.7. To do that, and to move it from the down to up position, here's the accompanying code. When I run that, you get the max required force is 0.82 pounds.
Okay. Okay, so one issue that I have with our design so far is that sometimes the wedge is too big to get into the gap, and sometimes it's too small, so it ends up going entirely into the gap.
But even if it goes through the gap, the door still stays open.
Well, also with the material we use like the plastic. I wish we could have used the rubber because it would damage the actual door on closing.
So, what do you think?
Okay.